This video will be for Lesson 5, Part 2. We are dealing with rational exponents now, and remember rational exponents are exponents with a fraction. And in Part 1, I introduced something called flower power, and I basically said if ever you're given a base with a fractional exponent, you want to rewrite that as a radical. So how a to the 4/5 would be rewritten as a radical is your base goes underneath your radical sign. And then you have to figure out using flower power, what's your root and what's your power. So roots grow below ground and roots are always in front of the radical like this. This is also going to be called later on, I'll show you, it's the index. And then the powers are above ground. So that's the power there, and that's where I'd write my power. How I would read this is the 5th root of a to the power of 4 is how that would be read. So going to class example 2 on page 95, what we're given now is we're given fractions, okay? And these fractions are with radical exponents. So a couple of things. If we don't have variables, we could type this into our calculator. So let's evaluate what this would be on our calculators first. So 9/4 in a bracket to the power of 3/2. So clear your calculators, open bracket, 9 divided by 4, close that bracket to the power of 3 divided by 2. We get 3.375, and you don't want to give your answer in decimal form. You'll always give it in fractional form or in rational form. So the answer is going to be 27/8. So let's just jot that down, 27/8. Okay, how do I express this in radical form? So it's the exact same thing as we did up here, except we have a fraction, and that's no big deal. What we do is underneath your radical sign, you put your base. And the base is 9/4. Then I look at my fractional exponent, and I say it would be, my root is 2. I will erase it. I'm just going to write it for now. And my power is 3. Okay, so that's how I would do that. And then from here, we know that I could erase this 2. Whoa, I'll fix that. So I could erase the 2. And then if I was to evaluate this on my calculator, so let's type this in, the square root of open bracket, 9 divided by 4, close that bracket to the power of, and then it was to the power of 3. I get that 3.375, and that converted to a fraction is 27/8. Okay, 27/8. Okay, what would we do if we have a negative exponent? So just to review, if I gave you a over b to the -3, so this was in lesson 3, was the negative exponent, you need to go from a -3 to a +3. And in order to do that, you take the reciprocal of your fraction. So it would be b over a. Then you could distribute that 3. So that would be b to the 3 over a to the 3. Okay, so jot that down because that's to review how we're going to do this. So applying the concept that I just showed you, let's get rid of that -3/2 and let's write that with a positive exponent. So to go from -3/2 to +3/2, you need to simply take the reciprocal of this. So 9/4 becomes 4/9. Then they want it written as a radical. So as a radical, it would be, I'm going to put 4/9 in my bracket. And I'm going to write, it's the square root of 2, I will delete that, and the power of 3. Okay, and let's get rid of that square root of 2. Or sorry, let's get rid of that root 2 because we don't need to write the invisible 2. And then we're going to evaluate this in our calculator. So first, let's do a couple things. Let's type in the original question to show you that you can type in negative fractional exponents. So let's type in 9/4 to the -3/2. So open bracket, 9 divided by 4, close that bracket to the power of -3 divided by 2. Math 1 fraction, and we get 8 over 27. And let's verify by typing this in, the square root of 4 over 9 to the power of 3. So let's verify that. So the square root of, open bracket, 4 divided by 9, close that bracket, to the power of 3. Math 1 fraction, 8 over 27. What I hope, another thing you see, some students will see this, 9 over 4 to the 3 over 2 was 27 over 8. 9 over 4 to the negative 3 over 2 is going to be the same answer, but the reciprocal. So the reciprocal of 27 over 8 is 8 over 27. Okay, let's do class example 3. You should be, I will do, maybe what I'll do is I'll do A and C with you, and then you could pause the video and you could do B and D to see if you're understanding this. So write an equivalent expression using radicals. So again, equivalent using radicals. So this would be the third root of R. This guy, I need to make positive. So that would be 1 over t to the 1 over 6. From there, that would be 1 over the 6th root of t. I don't need to say 6th root of t to the power of 1. Pause. Okay, b. That would be the 7th root of s to the power of 4. And d would be, there's two answers. So the first mark you would get is 1 over v to the 3 over 2. And the second mark is for writing that as a radical. So that would be 1 over the square root of v to the power of 3 would be your answer. Okay, class example 4. Consider the following powers. Explain why 3 of the above powers can be calculated, but the other has no meaning. So the first thing I want to show you is the following. Okay, I want everybody to type in on your calculators the square root of 25 and the square root of negative 25. So type both of those in your calculator. So 25 and negative 25. One of these will give you an error when you type it in. So if you type in the square root of 25, you get 5 as an answer. And if you type in the square root of negative 25, so square root of negative 25, you get an error. So that's what we call undefined, okay? The reason is, so this is undefined. The reason is 5 times 5 is equal to 25, but you can't multiply two numbers together and get a negative number, right? So what I want you to see, and we're going to talk about this a lot in Math 20-1, is if you have a square root, so I'm going to write the invisible 2 in, you could never ever take the square root of a negative number, okay? So for example, if I said, which one, without even typing this in your calculator, would give you an error, I hope you see it's this one. You could never ever take the square root, so that's going to be a 2, of a negative number. This would give you the error. This would give you an answer of 7. Okay? Now, the next thing I want you to type in is I want you to type in the third root of 8 and the third root of negative 8. Both of these will give you an answer. So that gives you the answer of 2, and that gives you the answer of negative 2. Here's the reason why. 2 written 3 times, 2 times 2 times 2 is equal to 8. So that makes sense. Negative 2 written 3 times, negative 2 times negative 2 times negative 2, that equals negative 8. So that one works as well. So what students need to see the pattern of is if you're taking a square root, you could never take the square root of a negative. If it's a third root, though, you can take the third root of a negative. So that being said, let's write all of these in radical form. Rewrite each of these in radical form, okay? So this one would be the third root of 64 squared. This one would, for B, it would be the third root of negative 64 squared. For C, it would be the square root of 64 cubed. And D would be the square root of negative 64 cubed. You should be able to look at this if you understand what I explained up here, and you should be able to say, okay, I could take the third root of either a positive or negative number. So if you type this into your calculator, it will work, okay? Can you take the third root of a negative number, right? So the third root of a negative number, and the answer is yes. You could take the third root of a negative number. This will work. This is the square root. So we're going to look at these two examples. This is a square root. If you type in 64 to the power of 3, you're just going to get a really big number. The square root of a positive number, this one will work. This one, the square root of negative 64 to the power of 3. That's going to give you the square root of a negative number, and we cannot do that. So the answer would be D, and you would say you cannot take the square root let me just erase below. So you cannot take the square root of a negative number. And again, if I punch this into my calculator, the square root of negative 64 to the power of 3, let's see what we get. So the square root, open bracket, negative 64 to the power of 3, I'm going to get an error. It is undefined. Okay, let's look at class example number 5, and we are not going to do class example number 6, and then I'll do one question in your homework. So class example number 5, I'm just going to get rid of this because I need to draw a cube. If you could draw, it says a cube has a volume of, so a cube has this volume. So somewhere on your page, draw yourself a cube. And the thing about a cube is that all side lengths are going to be the same. So I'm just going to write S, 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 okay? And the volume of a cube, so it says the volume of a cube is 60. Now we know that a volume of a cube is length times width times height. That's going to be S times S times S. So the volume of a cube is equal to S cubed. And then what they tell us is they actually give us what V is. So I'm going to take out V and I'm going to put in 60. So they say that 60 is equal to S cubed. And what A says is write a power which represents the edge length of a cube. So they want to know, well, what is S equal to? So here I have S. I need to isolate S to get what the side length is, okay? So in order to get rid of that 3, or sorry, that's the power of 3, the opposite of like squaring something is square rooting something. The opposite of cubing something is cube rooting something. So if you take the cube root of S cubed, you're just going to get S as an answer. And then we have the third root of 60. Okay. Now, A, I don't really like because basically what A says is it says write a power um, write a power which represents the edge length of the cube. So they want this written not with our radical exponent. And that's I'm going to be teaching you that in the next lesson, but I'm going to show you that here. How I would do that is I'm going in reverse of flower power, and that was my root. So roots go below ground, and my power is invisible. It's a 1. So the third root of 60 to the power of 1 is the same thing as 60 to the 1 over 3. If that doesn't make sense, I'll show you one more example. Let's say I said the fourth root of a to the power of 3. If I said write that in power form, it would be a, roots go on the bottom, and powers go on top. Okay? So the answer for A, write a power which represents the edge length of the cube. So they want what S is equal to. So S is equal to 60 to the 1/3. That's the answer for A, 60 to the power of 1 over 3. Okay. Write a power which represents the surface area of the cube. So if we were calculating the surface area of a cube, what you need is the area of one of the faces, right? So the area of one of the faces, which is area of one square is equal to side times side, which is side squared. And then you say, okay, how many faces are there on this cube? And there's 6 faces. So whatever this is, the area of a cube is equal to 6 times side squared. So you find the area of one of the squares, and then you're going to multiply it by S. Now, we know what S is, right? S is 60 to the power of 1/3. So if I erase this, area of a cube is equal to 60 to the power of 1/3. So I took out S and I put in what S is, and then I need to square that. Okay. From here, what do? We have a power to a power, and you multiply those two. So you multiply. On your calculators, if you're going to type that in, always fractions need to go in a bracket. So it'd be 1/3 in a bracket times 2, and that answer is going to be 2/3. So area is equal to 6 times 60 to the 2/3. And that would be your answer for B. Okay? C says use a calculator to calculate the edge length and the surface area. So the edge length is S, and we know that S is 60 to the power of 1/3. So on my calculator, 60 to the power of 1 divided by 3 is going to be this. And let's say it says to the nearest tenth, which is 1 decimal place, so that's 3.9. If the units for volume is meter cubed, this would be meters. Okay, so that would be your answer for the side length. The answer for your area is, this is your area. Let's calculate that. So on my calculator, 6 times 60 to the power of 2 divided by 3, and you get 91.9. Now I need to round this up. So the nearest tenth means I do need to have a decimal here. So I would round this to 92, and I'd write 92.0 would be my answer. Area is in meters squared. Okay, area is in meters squared. I'll help set up this on the homework question as well. Okay, so here's your work. 3 to 5. 6a to g, 8, 9, and 11. So just take a minute to get that circled. So 3 to 5, 6a to g, 8, 9, and 11. And the two that I'll do with you right now, I'll start number 8 for you, and then we'll look at number 11 together. So let's go over to number 8, which is very similar to what we just did. So if you don't understand number 8, or what we just did, watch over here. Okay, a cube has a volume of 216 centimeters cube. Draw yourself a cube. Label your cube. If it's a cube, it's side, side, and side. The volume of a cube is equal to side times side times side, because length times width times height. The volume of cube simplified would be s cubed. Then I'm going to take out this volume and I'm going to put in what they give me. 216 is equal to s cubed. And then from here, I need to isolate s because they want a power which represents the side length. So they want side length. In order to get rid of a cube, you cube root. What you do to one side, you do to the other side. So the side length is equal to the third root of 216. Writing that, they want it written as a power. So power means don't write it as a radical. So take that number, write it outside of your radical sign, and then let's figure out using flower power what our fractional exponent is. So 3 is my root. This is to the power of 1. So that's the side length of your cube. And then let's write, if this is centimeters cubed as volume, the units for side length would be centimeters. Okay. B, write a power which represents the surface area of a cube. Okay, so the surface area, painting that entire cube, we have 6 squares. So it's 6 times the area of a square. So that would be the area of the cube is equal to 6 times the area of one of the squares, right? Because one of the squares, when you find that area, if you multiply that by 6, you're going to get the whole surface area of the cube. And the surface area of one square is side times side, which is side squared. So that would be 6. Let's take out s, and let's put this in for s. So 216 to the 1 over 3. And then that's going to be squared. Area of a cube is equal to 6 times. When you multiply a third times 2, and make sure 1/3 is in a bracket, you're going to get 2/3. So 216 to the 2/3. Because we're dealing with area, the units for area, if it's centimeters, would be centimeters squared. And then C is just simply calculating that on your calculator, S, and calculating this on your calculator. Okay? And let's look at number 11. So why do I have number 11 starred? Okay, I want to show you two things. Let's say I gave you this as a multiple choice question on a test. You could simply enter that into your calculator, but then I'm going to show you the math, how you would do this properly. Okay? So 9 over 16 to the negative 0.5. How would you enter that? So let's clear this. Open bracket. 9 divided by 16. Close that bracket to the negative 0.5. Oops. Sorry. 9 divided by 16. Close that bracket to the power of negative 0.5. Math 1 fraction, we get 4/3 as an answer. So we know that the answer is going to be B. But let's say this was a long answer question and it's worth 3 or 4 marks. They want you to show you your steps how you would get this. So the first thing that I'm going to do is I'm going to say, okay, this is a negative exponent here. How do I go from a negative 0.5 to a positive 0.5? What do? You take the reciprocal. So that's going to be 16 over 9. Then what I want you to realize is what is 0.5 as a fraction? So hopefully everyone here knows that 0.5 as a fraction is 1 over 2, right? So if you really needed to, 0.5, math 1 fraction, and you get 1 over 2. Okay, how do I rewrite this as a radical, right? Because if we have a fractional exponent, we rewrite that as a radical. Square root of 16 over 9, the square root of 16 over 9. I'm going to erase that 2. This really, the square root of 16 over 9 is equal to the square root of 16 over the square root of 9. The square root of 16 is 4, and the square root of 9 is 3. Okay, so I could give you a question like this on a test and make it out of 3 or 4 marks. Students that don't understand how to do this, they're going to get 1 out of 3 or 1 out of 4 because they could punch that in their calculator. Students that understand this are going to be like, okay, go from a negative exponent to a positive. Then write that decimal as a fraction and then rewrite as a radical, right? Students who understand this will be able to follow what I've just done.